Welcome to lesson 4.8b, applications of polynomial equations. So today we're going to learn about what happens when objects are affected by gravity. So they get thrown up and then they come back down. So there are some formulas on how gravity affects objects on Earth, and they are going to depend on what units we use. But let's give the variables first. So my variable h is going to be the height of the object. At any given time. So it's something that's going to be changing. It's actually a variable. We have our t being the time measured in seconds. And we have a couple of more things that look like variables in our equations, but will actually be numbers. We have h with a little zero, h0, and v0. So h0 is the height at time 0. Or the initial height. And v0 will be that initial velocity. Think of that as the speed, so the speed at time 0. And there are two different formulas depending on how we're measuring the height. So we have one formula for if we're measuring the height in feet, and a different formula if we're measuring h in meters. And here they are. So most of these formulas are the same. The only piece that's different is this leading coefficient, which will depend on how we measure our height. So -16 if we're measuring in feet, and -4.9 if we're measuring in meters. So let's do a couple of examples using these formulas. So, in example 1, a ball is thrown upward from the top of a 98-meter tower. With an initial speed of 39.2, so we're throwing this ball up, and then it comes down. So, 98 meters is going to be the height that we start at, so that's h0, with an initial speed, this 39.2 is going to be that starting velocity. How much later means that we're looking for a time value. So time equals question mark. Hitting the ground means that the height is 0. So if we put this all into the formula that we want the formula for meters. So I'm going to grab this formula. H equals negative 4.9 t squared plus v0 times t plus h0, and I can plug in everything I know. So I know right now we're looking for when this ball is hitting the ground. So my h is 0. I'm looking for t, so it will remain in my formula. My v0 was 39.2. My h0 was 98. So let's go through and solve now that we have this formula. It equals 0. I'm hoping that I can factor. And I'm always going to check and see, is that really a GCF that I can pull out? So let's see, 39.2. Does that divide evenly by 4.9? It does. So what happens if I pull that out? Well, if I pull out a negative from here, the positive will become negative, and 39.2 divided by 4.9 is 8. Again, if we pull out a negative from a positive, it will become negative. And 98 divided by 4.9 is 20. So now I have this that can much more easily be factored. So we're looking for numbers that multiply up to a negative, add up to a negative. So negative 20 to negative 8, negative 20, I don't know, 2 and 10? Yes. If the 10 is negative and the 2 is positive, we will get this 2 factor. So, since we have equals 0, I'll just set each part equals 0. Either negative 4.9 equals 0. Well, it doesn't, so I'm not going to get any solutions from that part. Or t minus 10 equals 0. Or t plus 2 equals 0. So I will find that either t is 10 or t is 2. So, sorry, negative 2. So let's look back at my picture. T is measured in seconds. So I'm saying that this ball is going to hit the ground 10 seconds, positive 10 seconds later, or negative 2 seconds before it was thrown. So this answer here is nonsense. So my final answer to how much later will it hit the ground will be 10 seconds. Let's do another example. So a batter hits a baseball directly upward with a speed of 96 feet per second. So since I'm dealing with feet, I'm going to use my feet formula. This 96 is going to be my directly upward speed, so that initial velocity. And this h0, if I think about it, is going to be whatever height the ball is when the batter hits it. Okay. So we have this baseball player hitting the ball straight upwards, and then it's caught by the catcher. Okay, so let's set up the formula that I'm going to use. H equals negative 16 t squared. I know V0, it's 96, plus 96 t plus some height that I don't know. So how long is the ball in the air before being caught by the catcher? Let's assume, for simplicity, so we're going to assume that the catcher catches the ball at about the same height that it was hit. So the height at which it was caught is also h0. So for part A, where I'm trying to figure out when is this ball caught by the catcher, how long is the ball in the air? So this is t equals question mark that we're looking for. I'm going to replace that h with the height when it was caught, which we're assuming is the same as that initial height. And from here, I'm going to want to make sure it equals 0 so that I can solve. And this is looking very good. It doesn't even have a number part. So when I try and factor this, all I'm going to need to do is pull out that greatest common factor. So 96 divided by 16 goes in evenly. I can pull out a whole negative 16 t, which is going to leave me with just t from the first part. Remember, I'm pulling out a negative, so it'll become minus. And from the second part, I'll get just 6 remaining. So now I set each piece to 0. Either negative 16t is 0 or t minus 6 is 0. So let's look at these two answers and see which one makes sense. So unlike in the previous problem where one of the answers was nonsense, here both answers make sense. T equals 0 means that the ball is at this height when it was hit. That's true. Also not helpful. That's not when it gets caught, it's when it gets hit. And so this other number is going to be when the catcher actually catches it. So how long is the ball in the air before it's being caught by the catcher? 6 seconds. So I'm not going to cross off t equals 0 because it's not nonsense. It's just not when it was caught, it's when it was hit. So let's move on to part B. How high does the ball go? So this ball is going to be at its highest right in between when it was hit and when it was caught. So exactly between when it was hit and when it was caught. So we're looking for the average of those times. My t-value is going to be the average of these two. So right in between 0 seconds and 6 seconds is 3 seconds. So a time of 3 seconds is going to be when it is at its highest height. So if I want to know what actually is that maximum height, I need to plug it in to the formula. So let's do that. I'm going to get negative 16 times 3 squared, which is 9, plus 96 times 3 is 144. So how do I phrase this answer? Well, 144 is a height measured in feet. So how high does the ball go? It goes 144 feet higher than wherever it started. Excuse me. So we're looking for 144 feet above whatever that starting height was.